Growth Algebra 2 students, let's get this party started. I know that a lot of you guys are still in your ACT test, so I'm just going to cover some really important stuff for you. I'm going to do that while, what am I doing? I'm going to do that, and I'm going to record this session, so don't worry, it's all being recorded. You can ask me questions about this later. But what I have in front of me right here is your final exam for quarter 3. Preview. So, I'm sure that a lot of you guys are freaking out about it. And so what I figured I'd do is I'm going to go and I'm going to go over the different types of questions that I have on this exam. Sound good? Yes, no. I don't want you to do that. I want to be completely surprised. Come on, Bradley. I figured you'd be really down with this thing. All right. The first problem that I have has to deal with lines. You guys remember lines? Let's say I've got 2 lines that look like that. Obviously, I'm not going to give you the problems that I'm asking you to solve, but I'm going to give you guys, something. All right. Do you guys remember about lines? The only equation I remember about lines really is y equals mx plus b. We cool with that? Now, I do want you guys to know more than just y equals mx plus b. I want you guys to figure out, I want you guys to be able to figure out, well, what's the equation of this line? Because I think that the question that I ask is, at what points do these 2 lines cross? Cool? Oh shoot, I wasn't planning on telling you exactly the question that I asked, but, well, there it is. I accidentally did it. That's the first question. I wasn't planning on telling you that, but I guess I did. All right. So here's the things you would need to, you'll probably want to know. You probably want to know y equals mx plus b. If I give you a line, and I give you 2 points in which it crosses through, like say x1 comma y1 and x2 comma y2, you should be able to figure out the slope of that line. So if you don't remember, go back and look at our line section. We cool? And then from that, you should be able to figure out, like, if I gave you a line and I say, here's 2 points, tell me what the equation of that line is, then you should be able to get the slope using the slope formula, and you should be able to get the intercept using various formulas that you want to use. We cool? From that, you can get the equation for this line and for the equation for this line. And then if you want to figure out where they cross exactly, then what you should do is you should say, all right, well, I'm going to set the equation for this line. Say this is y equals mx plus b, and then say this one is, we'll make it y1 equals m1x plus b1, and this will be y2 equals m2x plus b2. Actually, I should just say y equals m1x plus b1, or y equals m2x plus b2. So this is line 1, and this is line 2. And in order to figure out where they cross, well, then I can simply say, all right, fine. You basically just set line 1 equal to line 2. You set them equal to each other, and then that will tell you the points where which they cross. Are we cool with that? Like, this has nothing to do with rational functions or quadratics or anything. This has everything to do with just straight up y equals mx plus b, or the slope equation, or perpendicular lines or parallel lines and all of that kind of stuff. All old school stuff that we covered in quarter 1. Now, you guys wouldn't think, he's going to give us that problem, and that he can get away with that. What I'm going to do is I'm going to say, I'll probably say something like, all right, let's pretend, I'm just going to make up numbers. This isn't actually the answer by any means, so don't write this down as far as like, this is going to be on the test or whatever, but let's pretend that this is negative 2x plus 5, and then we'll say that this is 3x plus 1. Now, why would I make that negative 2x plus 5? Well, because it's a slope going down, so that's why it was negative. And then what I did was, I'm going to ask you, well, if this is f of x, and this is g of x, then what is f of x times g of x? So really, you just take this sucker right here, multiply by that sucker right there. And in order to do that, you would FOIL it out. And then what you would do is you would get some kind of quadratic equation, right? Because you would have to FOIL it out and you'd get an x squared in there somewhere. And then I say, well, set it equal to 0 and tell me what the answers are. We cool? All right, so that's the first problem. And I literally gave you the first problem. Or I didn't give you exactly what the first problem is, but I told you things about it. The second problem looks kind of like this. Oh, any questions about the first problem? Yes, no? Are you happy? Is that intimidating? What? Okay, not bad. All right. The second problem is going to be one of these. It's going to be a vertical asymptote at x equals 4, negative 5, 10, something like that. And then it's going to say something like a x-intercepts at x equals 3, comma 6. I don't know, I'm just making it up. And then it's going to say something like a y-intercept at negative 2, and let's pretend this thing has a horizontal asymptote at negative 2. I don't know. I don't even know if this is like a correctly written problem. But what I'm asking you to do is, given this information, a graph has vertical asymptotes here, 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 and here. It has x-intercepts here and here. It's got a y-intercept here and a horizontal asymptote. Well, first of all, you can graph it. So let's see. At 4, there's a vertical asymptote. At negative 5, another vertical asymptote. At positive 10, 5, 6, 7, 8, 9, 10, another vertical asymptote. We cool? And then it's got y-intercepts over here at 3 and 6. And it also has a negative y-intercept. So I'm thinking it's going to come down like this. One of the things that I think is a key trait is I noticed that it has, well, it's probably going to come up like that. And then it's going to, let's see. I'm thinking it's going to do something like this. And then like this. Possibly. I don't know. It might actually the way I designed this is I'm thinking that one of these is actually going to be square in nature. Actually, wait, let's go this way. There. I have a feeling that one of those is going to be square in nature. And the reason for that is this. My vertical asymptotes, like my horizontal asymptote, if my horizontal asymptote were 0, then I know that my denominator, that the power of my denominator can be bigger than the power of my numerator. Does that make sense? Yes, no? Okay. But in this case, the power of my denominator is cubed over here because there's 3 numbers. And the power of my numerator is second power over here. And in order for this not to have a horizontal asymptote of anything but 0, there needs to be a cube power in the numerator, right? Because your vertical asymptote tells you, right, if we were to, the point is you don't need to graph it. What I really want you to do is be able to pull out an equation out of your head. So you say, okay, well, based off of this tells me that x minus 4 is in the denominator. This tells me that x plus 5 is in the denominator, and x minus 10 is in the denominator, right? That comes from the vertical asymptotes. Boom, boom. And then you say something like, well, based off of this, my numerator is going to have this, x minus 3, x minus 6. But here's the point is, the power of the numerator over here is a square, and the power of the denominator over here is cubed. And the horizontal asymptote is not 0. So I can't have a square over a cubed. I have to have a cubed over a cubed. Does that make sense? So I'm thinking that one of these is going to be squared like that. Because this would give me an x cubed on top as my biggest term. This would give me an x cubed on the bottom. I also have a feeling that I'm going to slap out a -2 out in front of here. I don't necessarily know if that's the right y-intercept. I know about this -2 because I want my horizontal asymptote to be -2. So if I were to multiply out the numerator over here, it would be -2x cubed divided by x cubed, simplifying to straight up -2. And then, of course, in order to input the correct answer, you're going to have to cube all of that stuff out and give it to me in that one form that you guys all hate. Any questions? This isn't the problem that's going to be on your test. There will be one that's very similar to it. And you've done many problems like this before, where I give you the boundary conditions, or the conditions that the graph meets, and then you guys tell me an equation based off of those conditions. Are we cool? All right. There's another one that I give you, which looks something like, I'm going to give you a graph. So I'm basically going to repeat this exact same problem, but instead of telling you about the graph, I'm actually just going to straight up give you a graph. And then I want you to tell me all of the things you see based off of that graph. Tell me the equation that you would get if you were to try to map out that graph. And can you use Desmos? Sure. Sure. Do me a favor though, if you use Desmos, let me know that you're using it. I'm not going to dock off any points, but I mean, it'd be cool if you can like just kind of, actually with this one it's all computer based, so you don't need to type in anything, but yeah. Are we cool? Okay. I'm going to warn you. So that's the 3 problems that are on the test. I think that's 3 of them so far. I think there's only like 7 problems on this test. So it's not going to be that crazy long. All right. There is another thing that I taught you guys how to do, and I think this was in Rational Functions Part 4 or something like that. I don't remember exactly. But it's basically simplifying rational expressions. And I think I can't make up a problem off the top of my head. I'm not that smart. But what I definitely can do is I can say something like, all right, if you have A over B minus C squared over D divided by C cubed over D squared or something like that. Okay. Yeah. You haven't seen this before, but what I'm saying is, let's do this problem. It's not that hard, actually. It's really easy. Okay. So in order to deal with this division sign, I'm going to take this fraction over here and just reciprocate him. I'm going to flip him upside down. Are we cool with that? So A over B minus C squared over D times D squared over C cubed. We cool? And then what I'm going to do is I'm going to say, all right, well, there's 2 C's on top and there's 1 C on, or 3 C's on the bottom. The 3 of them get canceled out, and there's only 1 left on the bottom. You guys see what I canceled and how I did it? Any kind of craziness that scares you, or are you good? All right. And then over here, this is just straight up like this cancels out with that. Yeah. So, oh, no. The first step I did was really easy. I didn't do any, I did one step. All I did was I just took this fraction and I flipped him over and I changed that division to a multiplication sign. That's all I did. That was the first step. I said, I don't like having a division sign with my fractions. I want to change it into a multiplication sign. It's that thing, Bradley, that what do you do? What do you do with a fraction over a fraction? Well, you take the fraction on the bottom, right? You reciprocate him and you multiply it. Right? So this thing is actually the same as Does that make sense? You've seen this before, right? So what I'm doing is I'm dividing a fraction. That's exactly what I'm doing here. I'm dividing a fraction. So what I'm going to do is I'm going to change that division sign to a multiplication and reciprocate him. I'm just going to take him and flip him over. We cool? So it wasn't any kind of crazy steps or anything. All I did was looks like A minus. Yeah, it is. This thing simplifies. Here, I'm going to erase this because you figure that out. This thing simplifies to A over B minus D over C. Are we cool with that? Can you make the dots? Oh, I did. There are dots. Let me just make them fat. Oh, I see. That's okay. All right. So you understand all of this stuff then? I see. I would have gotten really confused if that were a minus sign and all of a sudden it turned into a times sign. Yeah, I agree with you. But it was a division sign. That's how I turned it into a times sign. Cool. All right. And then this is just straight up adding fractions like you did when you were little kids, right? Like we need to find a common denominator, so my common denominator might be B times C minus B times C. Cool? And then this is a times c, because in order to make this denominator b times c, I needed to multiply by c. So I should have to do that to the top as well. And then this one over here will be d times b. Can we go with that? All right, and then now that they have common denominators, you can just straight up add them together. So I've got AC minus DB all over BC. That wasn't hard, was it? Cameron, yeah? No, not hard. Okay. Now you guys are trying to think, I think that what you guys are trying to think is, well, wait a second, but in what context did we do this? I don't remember doing problems like this at all. And my answer is, well, we actually did a harder version of this. We did a harder version of this. We did the, what if this were like, I don't know, x plus 3 divided by x squared plus 6x plus 9 divided by, and so on and so forth, and all of that kind of stuff. Do you guys remember this? And what the answer to doing that would be is to just, you take that denominator, you factor them down. So x plus 3 is on top. On the bottom you have x plus 3, x plus 3. Cool? And then one of these will cancel out with one of these. I mean, essentially, it's the same game that you're playing here. It's just instead of having just letter A, B, C, D, all of that kind of stuff, you have these parentheses with, you know, 2 different things inside of it. You got to keep track of all this junk. And I'm asking you to simplify it down to its most simple expression and then multiply it all out. Yeah. Yeah, all right, fine. Are we cool with this? That problem might look the scariest, but it's actually, I think, the easiest. It just looks the scariest. Okay, let's see. Oh, okay. All right, and then let's see. There's 2 more problems, so that would be questions 1, 2, 3, and 4. The 5th and 6th one are, I give you a quadratic equation. 5x squared plus 7x minus 12 or something like that. I don't know. And I ask you to find everything it is you can about that quadratic equation. I feel like we did this mostly in quarter 2, but a little bit in quarter 3. No, I think most of it was in quarter 2. So I asked you to find, well, what's the y-intercept? What is the factored form of the thing? What is the what are the zeros of the function? What is the does the graph have a maximum or a minimum? You know, you have a parabola that, you know, opens up downwards. What it's going to have is it's going to have a maximum because it's got a highest point that it reaches and then it goes back down. Whereas if you have a regular parabola that opens up upwards, it's going to have a lowest point. Right? Does that all stuff make sense with you? And then I asked, like, what is the coordinates of the vertex form? And so what you would need to do is remember how to put things in the vertex form, like using the completing the square technique. And you guys can go back to all my old videos and look up how to do this. I don't mind. I really don't mind you using your resources on this test. Cool? And then if you can successfully get into vertex form, I'm going to ask you these series of questions, which is actually should be really easy for you. If I were to take a regular parabola, you know, like the y equals x squared, and I were to transform it to make it fit this new parabola that that you did all this research about, what would I have to do? I would have to move it, up by how many units, and to the right by how many units, and then vertically compress it or vertically stretch it, and then flip it upside down or not flip it upside down. I don't know. You see what I mean? And that's talking about moving parabolas all around, that kind of stuff. And then let's see. There's one last question. The last question is the last question is I give you a cubic function. Now we're able to solve parabolas using the quadratic equation, right? We can solve parabolas using the quadratic equation, guaranteed. Cool? The thing that we have trouble with is what if we have a cubic function? There is no real equation to solve for these zeros of the cubic function. Actually, I think there is, but it's really advanced. So what we do is we say, all right, fine. If I give you one of the points that's on there, can you tell me the other two? And in order to do that, you're going to have to delve into that. Remember that polynomial long division that we did? We did that in quarter 3. I know that for sure. Yeah, you're going to have to beef up on that. And the last one is a question about. It's a question about a word. It's a word problem that has to do with a parabola that I got straight off of an ACT test. Cool. So, anyway, those are the eight problems that are on your final exam. Study for it. Make sure you guys know how to do each of those pieces, and I think that'd be pretty cool. I'm going to stop this archive, and then I'm going to start it up again.